Bismillahirrahmanirrahim. In this lecture, you will learn about the calculation of pH and pOH of acids and the bases. And in the previous lecture, you have already learned about the acid, bases, and the salt and the neutralization reaction. So let's start with the very basic information again. Let's suppose if you are having the acid and this is the nitric acid and nitric acid is HNO3, and when it dissociates it will give you the hydrogen ions, and this is the H positive plus OH ions, plus the nitrate NO3 and with the minus. So this is called the acid, and the example is the nitric acid. Why it is called the acid? Because this is going to release the hydrogen ions. That's why this is called the acid. Now the question is, how can we determine the pH of this acid? And let's suppose if it is having the concentration of zero point 0.1 molar. This is the concentration of this nitric acid, and of course when it dissociates into the hydrogen and the nitrate, and if you see this is the one molecule, it's going to release one and hydrogen ion and one nitrate ions. That means if you are having 1 mole of the nitric acid, it will release 1 mole of the hydrogen ions and 1 mole of the nitrate ion. And let's suppose if it is the 0.1 molar concentration, then of course it will give you the concentration of hydrogen ion, that would be 0.1 molar as well, because the ratio or the relationship between these two are 1:1. Now, how can you calculate the pH? This is required. The concentration of the hydrogen ion is required to calculate the pH, and there is very simple formula of the pH, that is the pH is the equal to, this is the uh, potential of hydrogen or the strength of the hydrogen, that is called the pH, and this is the small p with the capital H, that is the symbol of the pH, is equal to minus log of hydrogen ion concentration. This is the hydrogen ion concentration, and you have to show into the bracket. This bracket is showing the molar concentration, and this is the very simple formula to convert the hydrogen ions to the pH, or to calculate the pH of any of the acid. Let's now I'm going to calculate the pH of 0.1 molar nitric acid, which is giving you the zero point 0.1 molar concentration of the hydrogen ions, because in the pH, H belongs to the hydrogen ion concentration, P is the potential or the strength of this ion. That means P is belongs to actually minus log from as given in this equation. So minus log of the concentration of hydrogen ion is 0.1 molar. Now you have to take the logarithm of zero point 0.1 molar, and I'm going to take the logarithm by using the calculator. And here this is, you have to just put 0.1 molar of the log, you have to take the log, that will give you the answer minus 1. So this is the answer. Now I'm going to put in the formula here. Again, pH would be, this minus is coming from the formula, and the log of zero point 0.1 would be the minus 1, and now minus multiplied by minus is plus. The pH of this solution or the nitric acid is 1 molar concentration. And in a similar way, let's suppose you have another example. This is the H2SO4. H2SO4 is having the formula of this, and this is called the sulfuric acid. Now what is happening, it is going to dissociate with the two hydrogen ion, and that's why I am putting over here, this is the hydrogen ion plus SO4, SO4 minus 2. So here, because hydrogen is having positive 1 charge, so there are two positive 1, that's why in the sulfate is having the charge of minus 2. So this is again, if I ask why did you call it an acid, because this is going to release the hydrogen ion, that's why this is called the acid. And this particular formula is for the strong acid and the bases to directly calculate the pH by using this formula. So again, let's suppose if this sulfuric acid is also having the concentration of zero point 0.1 molar, sorry, this is the 0.1 molar concentration. Now, how many total hydrogen ions are produced with the zero point 0.1 molar uh, concentration, or what would be the concentration of the hydrogen ions if this sulfuric acid completely dissociates into the hydrogen ions and the sulfate ions. So of course here the molar ratio between the sulfuric acid and the hydrogen ion is 1:2, because 1 mole of the sulfuric acid is going to produce or going to release 2 moles of the hydrogen ions. So that's why the concentration of hydrogen ion after taking the zero point 0.1 molar concentration, that would be the multiple of 2. That means you have to multiply by 2 with the zero point 0.1 molar concentration here. And what would be the final concentration? That would be the 0.2 molar concentration. So this is important over here. If there is the acid like this, sulfuric acid, to calculate the pH, first you have to consider the total number of the mole or the molar concentration of the hydrogen ions, and in this case it will be the double of the uh, acid concentration, because this acid generates or releases two hydrogen ions. Now again, we will use the same equation, pH equal to minus log hydrogen ion concentration. Now minus log of hydrogen ion concentration, and here hydrogen ion concentration is zero point 0.2 again. So I'm going to take the log. This is coming from the formula. Let's see what would be the answer of the zero point 0.2 molar concentration. So again, you can use the calculator. So this is zero point 0.2, this is the log, and the value is minus 0.698, minus 0.698. So again, minus 0.69 and 8. And again, if minus multiplied by minus, it would be the plus. The answer would be 0.698. That would be the pH of zero point 0.1 molar hydrogen sulfuric acid. So this is the way you can calculate the pH of any of the acid. Now I'm going to calculate the pH of base. pH of any of the base. And example over here is, let's suppose this is the sodium hydroxide. This is the base, and because this is going to release sodium ion plus OH ion, and due to this hydroxyl ion and the releasing of the hydroxyl ion, this base is this compound is called the base because this is going to release the hydroxyl ion. Now the question over here, what would be the pH of this base? And another example is, let's suppose I am taking the concentration over here is the zero point 0.1 molar concentration. Again, if you consider over here the ratio between the NOH and the OH is 1:1. This is the one molecule, and one molecule is going to release one molecule of the hydroxyl ion. And if it is 1 mole, this is going to release 1 mole of the hydroxyl ion. If it is 0.01 mole, of course, this would be going to release the 0.01 molar of the hydroxyl ion concentration. So this is the first step you have done over here. Now what would be the pH? Similar to the pH, you can also use the formula over here. This is the pOH. pOH will be equal to minus log of, again, this is the OH concentration. So just you are replacing the OH with the H, and that is the same formula as you have used for the acid to calculate the pH of the acid, and now you are going to calculate the pOH for the base. So because the base are releasing the OH ion concentration, that's why this is called the pOH, and for the acid you have to use the pH. And again, now directly put the value over here. What is the concentration of OH ion? And this is the 0.01. And now you can take the log of 0.01. Just this is from the formula, and let's see what would be the answer of this one. So again, use the calculator. Now you 0.01, and this is the log. Answer is minus 0.2, and I'm going to minus point, sorry, this is the minus 2, and the answer would be 2. So this is how you can calculate the pOH of the base. And let's suppose there is another example. This is the calcium hydroxide, and formula of this one is the CaOH twice, and when it dissociate, it will give you the calcium plus 2 plus OH minus, and there will be 2 OH, because these are the two hydroxyl ion, and it will give two hydroxyl ion, and then each hydroxyl ion having the charge of -1. So there are two, that's why the calcium is having the +2 charge. Again, let's suppose if it is having the concentration of point 0.1, the same, I'm using the same concentration, you can use any of the concentration. So here the ratio between COH twice calcium hydroxide and the hydroxyl ion is 1:2. That means each mole of the calcium hydroxide is going to produce 2 mole of the hydroxyl ions. So that's why the concentration of hydroxyl ions would be double to the concentration of the calcium hydroxide. So this would be the 0.01 again, and the answer would be the zero point 0.02. So this is your first step. You have correctly calculated the concentration of the hydroxyl ion. Now use the same equation to calculate the pOH. So pOH over here is the equal to minus log of, this is 0.02. So again, you can use the calculator to convert the concentration or to the pOH, and the answer would be here. This is 0.02, taking the log, that will be equal to minus 1.69, equal to minus 1.69. So the answer would be minus multiplied minus is plus 1.69. So this is the all about the uh, pOH of the base. Now the question over here, you can also convert this pOH into the pH. So the first step is to calculate the pOH, and then you can also convert into the pOH, and I am using the very simple formula because the scale total pH plus pOH will be equal to 14. This is the third very simple formula. You can calculate the pH of the base and pOH of acid, or directly or indirectly you can convert any of the value into the other one. So here I'm using the same. Let's suppose this is the pOH of the base is 2. So this is, now I want to calculate the pH of this base, because pOH is 2 and equal to 14, and the pH will be equal to 14 minus 2, that would be equal to 12. So this is very simple formula. You can use this formula to convert the pOH into the pH and pH into the pOH. And similarly, you can do for any of the other calculations I have done over here. So this is all about our today lecture. And in this lecture, you have learned how to calculate the pH of the acid and pOH of the base. And later on in the third step, you can also use this formula to calculate the pH if pOH is given, and you can calculate the pOH if pH is given. So this is all about our today lecture.